To the second tutorial on the RT software. In this tutorial we are going to run an analysis, in fact several analyses, and to do that we need to have objects created that will be visible over in the objects pane that I'm collapsing one branch of right here now. So we need parameters, we need functions, and depending on the analysis we may need some models. Also in the analysis part we are going to need solvers and various tools that are in the branches of the analysis part of the objects pane. In later tutorials we're going to go through how to create these manually, but in this case I'm simply going to load these objects from an input file. So I could go to File, Open, and look at the file, or if you find it more convenient you can go to your File Explorer or your File Finder and you can drag the input file onto the application, onto the RT application, and that serves the same purpose. So here we have random variables created, we have functions created, but in this case the models are not going to be in focus, so I'm collapsing that branch. What I will do first here is to study function number 1, and let me go down and look at the expression here that we have. Looking at this, we have two terms. Here's one, this is the last one. Here's another term. As I'm moving in front here, we have the a 1 minus in front. What I would like to do first is that I would like to remove that 1 minus, and I will put a parenthesis in the front, and then I would add these two terms. So I put a plus sign in between here and a parenthesis to complement the one I put in front, and I will consider this as some kind of response from an engineering analysis, and I'm first curious what is the sort of probability distribution of that function. I'm getting a handle on that by going to sampling and doing a histogram type of sampling analysis. Starting that, what is appearing in the plot here is the histogram that is being generated from realizations of these functions as this function as the random variables are being created. So not to have this analysis run for too long, what I'm going to do, I'm going to go to the analysis part and go to the histogram accumulator. Here's the number of samples that will be created, and in a later tutorial we're going to show you how you can run the analysis much faster. But in this case I'm just going to reduce this number of iterations to a very low number, and there the analysis stops. And we have at least a tentative overview of the probability distribution for this function. What we will do now is that we will start to focus on the probability of exceeding 1. So here's 1 on the abscissa axis, and let's try to find out what is the probability of exceeding 1. What I will do then is to go back to the domain part of the objects pane, click on my function, and now I will be interested in setting in front 1 minus, so that we start to assess the probability of the terms in the big parentheses exceeding 1, the sum of those two terms. Clicking enter and going to analysis form. There's an analysis tool suggested for me. That's one of the ones created from the input file, and I'm going to click OK to that for now. And the analysis converged with a beta equals to approximately 1.8 and a corresponding failure probability of 0.036. And the plot that was created, that is in the red line, it's essentially the reliability index as it converges. It converges to 1.8 in this case. So essentially that shows the distance from the origin in the standard normal space to the various trial points. Trial point number 1 being here, trial point number 2 being here, and trial point number 3 being here. The blue line shows the distance from the previous trial point. So as the form analysis converges, you'll see that the distance from the previous trial point is very small. So this kind of plot is very useful when you struggle with convergence of form analysis. The next thing I'm going to do is to run a sampling analysis to try to verify the accuracy of this failure probability. So the reliability index of about 1.8. Let me do that by first going to close all the plot windows to make ready for the next plot that's going to appear. Then I go to analysis sampling again, but this time choosing a different type of accumulator, namely a different way of post-processing the samples. Actually, before I go ahead and do that, I want to make a bit of a change in that failure accumulator. So I'm going to press cancel for now and go to the analysis part of the objects pane and click on this failure probability accumulator, and I realize here I have a target coefficient of variation on the failure probability equals to 5%, and that is fairly small. It's reasonably small, so in a normal analysis you should certainly go for that or lower, but in this case it is a bit high because we want to wrap up this tutorial pretty fast here. So I'm going to set a coefficient of variation equals to 20%. I'm going to click OK to that, and let me go back to try to start the sampling analysis, choosing now my failure probability accumulator, pressing OK. So what is being plotted here now is a plot of the coefficient of variation of the failure probability, namely a sense of the accuracy of your sampling analysis. And you can see that it approached 0.2, namely 20% fairly rapidly. So here we have the end point. So after less than 600 samples, we have the result here. The beta is approximately 1.8, seems to verify the form analysis, but keep in mind that 20% coefficient of variation is extremely high. We would like to push this down to at least down here to 5% before we really could start trusting the sampling analysis or the accuracy of the sampling analysis result. So that was a bit of an introduction to the running analysis in RT, and later tutorials coming up on how to create analysis tools and how to change parameters during runtime to make the analysis go faster.